Good day, dear participants of conference. My name is Sergey Dyadun. I am PhD on Technical Sciences, Associate Professor of the Department of Modeling Systems and Technologies of Karazin-Kakao National University. The theme of my presentation is Information Technologies to Estimation the Effectiveness of Water Supply Systems, control depending on the degree of model uncertainty. The main purpose of this research was to develop an algorithm for solving the task of estimating the efficiency of water supply systems, control depending on the volume and composition of operational information about the object under control and carrying out the corresponding analysis. By quality of functioning of water supply system is understood probability of its purpose to supply water to consumers in necessary quantity under the set pressure according to requirements on an interval 0t. The efficiency of water supply system functioning is understood as the cost of a resource, water, electric power, for providing the preset quality of its functioning on the interval 0t. The efficiency of implemented control depends on the degree of adequacy of used object models. In order to obtain estimates of control efficiency of water supply systems on the time interval 0t, depending on the degree of uncertainty of the object model, i.e. on the volume and composition of operational information about its states. A simulation model of the real water supply system functioning was used. The main research results of this work are: the efficiency of implemented control depends on the degree of adequacy of used models of object. Introduces the criteria characterizing the degree of closeness of obtained solutions when using different types of models of control objects. The algorithm of estimation of quality and efficiency of water supply systems control depending on the volume and composition of operating information about the object under control is presented. Carried out research have shown that for maintenance of optimum values of criteria of quality and efficiency of water supply systems functioning on a control interval, it is enough to have pressure measurements in all local dictating points of a network. Further increase in number of measurements does not lead to improvement of these criteria values. Research were carried out with the use of simulation modeling method of real water supply system functioning. The next slide presents the conceptual scheme of information technology to support operation control in water supply system. The process of operational control of water supply system is divided into two stages: operational planning of modes of functioning of water supply system and their stabilization. The solution to the problem of operational control of the functioning of water supply system is achieved by decomposing the original problem into a number of hierarchically related tasks. Consider the structure of solution problems of operational control of the functioning of water supply system, slide 4. Based on the operational information, getting simultaneous data from sensors installed as control points in the network. The task of identification of the state of the flow distribution in water supply system is solved. The multiplied solution of this task allows to determine for each node of water supply system model the vector of evaluated water consumptions, which is then used as a series to predict the water consumption of each of these nodes for the entire control interval. The solution of the task of predicting the values of nodal water consumptions for a given time interval is the input source information directly for the problem of operational planning of the operating modes of water supply system. The solution of the problem of operational planning of the operational nodes of water supply system is determined as a result of solving of the sequence of tasks. For each discrete time instant k equal 1 to k big, the task of the optimal load distribution between pump stations is solved. As a result of its solution for all k equal 1 to k big, the values of water consumptions and pressures at water supply system outputs are determined, which ensures the pressure in the nodes is not lower than the set ones. To ensure the obtained parameters of water supply system outputs as a result of solving for all k equal 1 to k big, the task of optimization the pump station operating mode for all of them are determine the optimal structure and parameters of its functioning. The described sequence of solving the operational planning problem makes it possible to obtain a solution that is invariant with respect to the predicted level of stochastic disturbances, which guarantees the necessary quality of water supply system operation over the entire control interval at maximum efficiency. The pressure stabilization of the dictating points of water supply system partially compensates for disturbances acting on the control object in order to prevent the regime parameters from exceeding the permissible range. Research results. Let's denote L set of pump stations water supply system, M set of trunk sites water supply system, N set of nodes of a network with consumers, HI, QI, pressure loss and the expense in ICE site water supply system, H input, Q input, H output, Q output, pressure and the expense on an input and an output ICE pump station. Let us introduce the criteria characterizing the degree of closeness of the obtained solutions when using different types of water supply system model. We will evaluate the effectiveness of solving the problem of controlling the modes of operation of water supply system on the basis of an aggregated model with respect to solving this problem on the basis of a complete water supply system model, which is taken as a standard. On set L of all water supply system inputs, we will introduce a measure characterizing the degree of closeness of the values of the variables determining their states when solving on the basis of an aggregated and complete water supply system model, Formula 1. Since the variables H output, Q output are measured in different units, the use of measure 1 makes it possible to bring disparate scales to a single dimensionless one. In addition, let us introduce a measure characterizing the maximum deviation on the variables Q output, H output that determine the states of the water supply system inputs from their optimal values Q output star, H output star. Formulas 2 and 3. The following slides present the algorithm for estimating the efficiency of water supply system control depending on the degree of uncertainty of the control object model. The algorithm is described in detail on slides 10, 11, 12, but in the limited time I will not have time to read all points. Analyzing thus a different number and composition of observed variables h, j, k equal 0, -1, -2, we will receive estimations of quality criteria and efficiency of water supply system functioning on a control interval 0t, and also estimations of criteria 1 to 3 characterizing a degree of closeness of optimum decisions resolved at n time of corresponding value of an error at the expense of incompleteness of composition of the operating information on an operated object. In the corresponding level of stochastic environmental perturbations is set, this algorithm can be extended to the calculation of the estimates of the efficiency of water supply system control depending from the degree of uncertainty of the models of the control object and the environment. Software for implementation of modeling and operation control tasks of water supply systems. Currently, all software is implemented in C++. Some tasks on accordance with agreements at the request of water supply enterprises are implemented in other programming languages and tools, especially using standard software package AppNet 2. The developed databases were implemented with MS Access. Conclusions and future work. The conducted research have shown that for maintenance of optimum values of criteria of quality and efficiency of functioning of water supply system on a control interval 0t, it is enough to have precise measurements only in all local dictating points of a network. Further increase in the number of measurements does not lead to improvement of this criteria. The use and widespread adoption of information technologies of optimal control operation of water supply system allows in practice to improve the quality and effectiveness of their functioning by reducing the excess pressure in the networks and consequently reducing introductive costs of water, reducing electricity costs, reducing the probability of occurrence of emergency situations in networks. Thank you so much for your attention.